To be here with everybody. So I'm going to share my screen and I'm going to be talking about EarthGrid, and what you're going to hear is going to sound a bit like science fiction coming to life, because basically it is. What you're seeing here are two plasma torches. You can think of them kind of like lightsabers, and they are turning hard limestone rock into little bits of rock, as you see there. I'll get into that a little more. Kevin already mentioned a little bit about my background, but four meaningful exits, including a Deca unicorn. That company was Tradewind Energy, which was the largest developer of wind farms in the United States in 2017. I think it was number three in 2018. It's now a $35 billion division of Enel Green Power, which is one of the largest clean energy owner operators in the world. And my former company is a huge part of their portfolio. But most of my companies have been in clean energy. All of my companies have been in infrastructure for the most part, other than a couple of, passion projects. So some of the problems we're trying to solve include data centers. As I think everyone is aware of, data centers are using a lot of power, and that's increasing, and AI is going to increase that power, that data center demand by about 5x. Some are saying we need a $20 trillion upgrade to the grid to support the clean energy transition. So huge opportunity to do that. As Kevin already mentioned, I've been writing about the need to upgrade our grid in North America for over 20 years. And close to my heart, 80% of all solar and wind projects are abandoned. And that's after a 3 to 7 year wait, meaning you start developing a project, it takes 3 to 7 years to do the grid studies, to get your permitting and so forth. And then when the grid studies come back, often the cost to upgrade the grid, the aging, antiquated grid, is so high that it either kills the project, or the project is put on pause or on hold until enough other projects come along where everybody can share those major upgrade costs for our creaky old grid. And so it's frustrating because solar and wind are the cheapest form of new energy generation, and they're the fastest to develop, permit, and build, way faster than getting a permit for a nuclear power plant, as you can imagine. Solar and wind is much easier to permit, but the grid just needs massive upgrades. Underground power lines are 9 times more reliable than overhead lines, according to U.S. utility data. But historically, they're 7 to 20 times more expensive. So why haven't we done this? It's because of the cost. Overhead lines, though, are subject to risk from whether it's causing fires or being damaged by fires, ice storms, tornadoes, hurricanes, traffic accidents, wildlife. Squirrels and other things can cause shorts in power lines. And again, if they're underground, they're much more reliable. 10 times fewer truck rolls with nine times greater reliability. And overhead lines, in terms of building a new one, particularly an overhead transmission line, takes forever. The typical range is 10 to 20 years to permit and build a new overhead line in the US. Give you an example: the SunZia line from New Mexico to Arizona and parts of Southern California. That project has been in development for now 18 years, and they still haven't started construction. That's typical. And most of those projects never get built because local communities will stop them. NIMBYs and bananas will show up at community meetings and complain about it. Oh, it's going to give my kids cancer, or it's going to lower my property values. It's ugly, blah, blah, blah. If you haven't heard the terms NIMBYs and bananas, NIMBYs, not in my backyard. Bananas, that stands for people who who believe to build absolutely nothing anywhere near anyone. That's kind of their motto. And I have one of those in my neighborhood, actually. Undergrounding power lines is a lot faster. Again, it's historically more expensive, but you can get the permitting and the construction done in 1 to 3 years. But it's always been so expensive until now. This image you see on the right is our first commercialized machine digging a trench in hard granite. And this trench is about a 30-meter long trench, roughly 100-meter long. It was a demonstration. You see these granite chips just flying out of the ground. We had construction companies and data center companies, grid operators, other people coming to check this out. And they were just the people who know how to deal with granite. They were pretty shocked at how fast we can go through this stuff. And because we lower the cost of undergrounding by 90%, we can now put new power lines in at about the same price as overhead lines, maybe a little less, maybe a little more, but way faster, by an order of magnitude faster. So here's our two machines. On the left is a tunnel boring robot, and on the right is the plasma excavation system, which I already kind of showed a little bit. PES for short. So the plasma excavation system is fully commercialized. We actually did, as I mentioned, we did demonstrations in California near Yosemite National Park, and then we shipped it to Norway, did a series of demonstrations there for dozens and dozens of people. Now we're bidding on over 7 projects in Europe and a handful here in the US with utilities and data center developers. On the left is our tunnel boring robot. And for scale, it's boring a hole about 1 meter in diameter, around 37 to 39 inches or so. I prefer metric. And this is going through a granite cliff that you can see here in the background. And I'm very excited about this. We're at this inflection point. I came up with this idea thanks to a Navy SEAL who inspired me years ago. I can tell that story if you want later, but I've been waiting for this moment for almost 10 years, and we finally have developed all of the subsystems, including spoils removal, getting stuff out of the tunnel, and thermal management and navigation guidance and other controls to where we have this thing fully built and ready to go. That should be commercialized by first quarter of next year. So 2 different platforms, a tunneler and an excavator. And the excavator can do trenches, like I said, but it can also carve out caves or caverns underground. It can carve out foundations. It can carve out a channel for a boat to float through. I mean, there's really no limit. If you want to remove hard rock, this is a way to do it without any chemicals or without using water, and it's vibration free. So now I'll kind of explain how the tech works. You see these tubes on the end of the excavator. Basically, instead of a bucket at the end of the arm of the excavator, we have these 2 plasma torches, and it can be 2 or 6 or 15 plasma torches or whatever. But in this case, there's 2, and you see the tubes. We create lightning inside that tube with electricity. So it's just a really hot electric arc that we create in there between a cathode and an anode. And then we pass air through the tube at nearly the speed of sound. And so you have incredible kinetic energy coming through because of that airflow, combined with the air that superheats into a plasma at 27,000 degrees Celsius around the core and around 6,000 degrees around the edges. So the kinetic energy and the thermal energy, along with a little bit of sound and light energy, which is fairly de minimis, that turns everything into sand and dust. And then we use powerful vacuums to remove that, and the sand and dust is valuable. We can actually sell that, our spoils. Unlike everybody else, they have to pay to get rid of their muck because it's got chemicals and lubricants and water and all kinds of stuff in there, and they have to pay to dump it at, the local landfill or whatever, if they can even find one. In some cases, like in California, there's only like 2 or 3 water treatment facilities that'll take the wastewater from those things. We don't have any of that. Our spoils can actually be used for concrete. So that's basically how the tech works. It's non-contact, it's vibration free, no water, no chemicals, no bentonite, no drilling mud. All right, going to move on here. So that tech enables us to have some pretty powerful competitive advantages. We're up to 10 times lower cost, anywhere from 10 to 100 times faster. And here's some of the stats. For a walkable tunnel of 2.5 meters in diameter, I'll get the laser pointer out so everyone can see a little better what I'm talking about. 2.5 meter diameter. Typical cost for a concrete lined tunnel in North America or Europe is around 5 to 9 million per kilometer, a little bit more than that per mile. EarthGrid's cost, not what we would sell it for, but our cost is about $500,000 per kilometer. And so as a result, we're, in this case, up to 10x lower costs, and we would probably sell it for like 2 million per kilometer and have really nice margins. Speed is also really important. Construction projects have ongoing costs with equipment rentals and project managers on the job. And so the longer the job takes, the more expensive it is. So the faster you can get it done, obviously on the contrary. In granite, a typical day is 10 to 30 meters. We've demonstrated up to 1,000 meters a day, up to a kilometer per day. We measure in millimeters per hour. And we know even without optimizing our tunnel boring robot for speed that we can do 200 to 300 meters per day, which is still significantly faster. And then again, the undergrounding saves time on permitting by basically instead of 15 years, we can do it in 15 months. We do have a lot of patents, 162 patent claims that have been filed. They're published all over the world. More importantly, we have over 1,200 trade secrets. And these are things we'll never patent, kind of like the Coca-Cola secret formula. We won't patent these, and they're things like our recipes for each kind of rock. Over the last 7 years, we've done over 1,000 tests, over 100 different rock types, and there's 7 variables we can modify to optimize our rate of progress. So those are the recipes that we don't want to ever patent, and we think that gives us about a 4-year defensive moat, if not more. Plus, we have key exclusivity with suppliers. So our revenue model, we're not going to sell these machines. We don't want to be Caterpillar or John Deere. Instead, we have a sense of humor, so our products are badass and boom. Badass stands for boring and drilling as a simple service, or boring and digging. And that's our construction model on the left that you see here. Margins will be 60% plus once we get the machines up and running and the market acceptance is there. And we're just at that point where we're starting to do that. Our first few projects are going to start. We expect to get contracts for a project in the eastern US with a utility, hopefully by the end of January, and some contracts in Europe, in most likely Norway and Iceland will be the first two locations. On the right is our boom model. That's build, own, operate, and maintain. You can think of this kind of like underground real estate development. We actually trademarked the name TerraSpace in addition to boom and badass. So effectively, we'll own the tunnel and either we'll lease out space inside our tunnel, like leasing out a building, and we'll collect lease payments for decades, or we'll put our own lines in there and we'll collect a toll on all of the commodities flowing through the tunnel. So that could be data, water, power, freight, and eventually people, and we could get a piece of the action on everything moving through the tunnel. And you might be asking yourself, okay, that sounds great, but how in the heck are you guys going to own your own tunnel? Well, we have a hack for that. I'll get to that in a couple more slides. Some examples here. Here's a badass project, again, a construction project. You see Chad standing in a hole in the granite that we carved out with our excavator. This is called a ground vault. Utilities need these to splice their pipelines or their power lines together. In the case of, say, PG&E, which is one of the largest utilities in the country, they need these every 850 feet. And they've announced plans to bury 10,000 miles of power lines in California. And so you can do the math on how many ground vaults they need if you're looking at every 850 feet. That's, tens of thousands of these things. And if it's in rocky soil or in the hills or mountains where it's a thin layer of topsoil and hard rock underneath, they can't use dynamite if they're anywhere near a structure. And so it's jackhammers or rock saws, which are slow and expensive and costly, and they're changing out drill bits and heads all the time. So we're faster and cheaper. Anyway, that's an example there. A customer can get some savings. The job can be, 10,000 a day or 100,000 a day, depending on the size of the job. And then here's an example of a boom project. We have one in Texas and one in Nevada and California that we're actually actively developing. In this one in Texas, we have signed a contract to buy solar power. Now we need to find customers in San Antonio or Austin and move the power, from point A to point B. This project would have $800 million of CapEx. And that sounds like a lot because it is, but this is the exact kind of thing, Ben and I have each been around infrastructure projects, and I have arranged non-dilutive project finance for solar farms and wind farms in excess of $10 billion. I've been, involved in projects helping to arrange project finance for that kind of thing. There is so much capital out there for good quality infrastructure projects. Well, a tunnel project would be the same thing. Just like if you get a power purchase agreement to sell solar or wind to a utility or a data center or a Fortune 500 company or whatever, if we get a tolling agreement or a PPA to sell power or data or water to a creditworthy customer, Bank of America and Morgan Stanley and the Kuwait Investment Authority, Sovereign Wealth Fund, have all been talking to us about providing project finance capital for these projects. So it would be non-dilutive capital that would be, it would be a subsidiary owned by EarthGrid. It will generate cash flow for decades, because tunnels are always designed to last for basically a century, and it would be non-dilutive. But the downside is there's no revenue at all until the project's built. The upside is, well, there's two major upsides: revenue for decades, and again, it's non-dilutive capital. And by the way, the construction loan that would be loaned to the LLC formed to own each of these tunnel projects, those loans are non-recourse to the company, which is great. Here's a slide showing some of the logos of the companies we're talking to. There's tremendous interest. I think we have over 20,000 contacts in our HubSpot database of customers that have been following our progress over the last number of years. On the right, you see the actual tunnel boring robot cutter head, 3 torches there. These arcs are where the vacuum inlets pull out all of the sand and dust. And then you see these nozzles that create a clockwise vortex, basically a tornado. The engineering team calls it a hailstorm, but basically it's a violent movement of air clockwise, which breaks up all the bigger chunks of rock that are, flaking off of the rock wall, and breaks those up. And that, abrasive hailstorm, if you will, breaks all of that up into sand. and that's easy to vacuum out in a solid state manner, meaning no moving parts for the spoils removal. Okay, here's the hack. How do we own the tunnels? EarthGrid over the last 5 years has been approved as a regulated telecommunications utility, not an electric utility, but a telecommunications utility, so far in 46 states, which represents 97% of the US population and GDP. So that's a pretty big deal. Like I said, it's taken a while. I'm going to speed things up. I said, 15 minutes. I'm going a little longer because I'm giving a little more information. But basically, as a utility, we get what's called a CPCN, a Certificate of Public Convenience and Necessity. And because it's for the public benefit to add more fiber and and water and power and things like that, we as a utility get effectively guaranteed access to put our tunnels under any public road. We can't go into somebody's house without their permission, but any public road or public land, we can do that without any public comment period. So the NIMBYs and bananas I talked about earlier, they have no opportunity to show up at anything to complain about it because, again, we're a utility. All right. Leadership team, Mark Park, former Rivian leader, building electric vehicle platforms. Ben and I are on the call. So you see the team here. Here's our board on the right. Amazing people on the board. And I'll just wrap up quickly with a couple more slides. Advisory team, this is just some of them, but I'll highlight Rochelle Chong, former California Public Utility Commissioner. Then she went on to be a commissioner at the federal level for the FCC, telecommunications. Similarly, Kurt Hebert was a state and federal regulator. He was the former chairman of FERC, the Federal Energy Regulatory Commission. That's the top energy regulator for all energy in the United States, Canada, and Mexico. And he was the commissioner there. Audrey, former COO of PJM, the largest grid operator in the world, and former chairwoman of the New York Public Service Commission. So very well connected, powerful, and experienced people on the advisory board. All right, here's our fundraising history. My family office bootstrapped the company for the first 5 years. Every round has been oversubscribed. We are currently raising a Series A. We're calling it a commercialization round. We're raising 7 million, 95 million pre-money valuation. So that implies 102 million post-money. And we do have $32 million of assets on the balance sheet. So that does make this round and all previous rounds eligible for QSBS tax benefits. We have 2 lead investors that have already signed a term sheet. We've already raised the first 2 million in this round and have commitments for another 1.5 million. And it's only been open for about, 7 weeks or something like that. So it's going well. We expect this round to oversubscribe, and it is a priced round. It's not a SAFE or a convertible note. It's an actual price round. And the last slide, here's the use of funds for the 7 million. Working capital and R&D are the bulk of it, but we do have $1 million set aside to finish the development of those 2 boom projects I was talking about in California and Nevada, and the other one in Texas. Last thing I'll say is everyone who invests before the end of the year, even though we've hit our $2 million threshold to trigger the lead investment from our 2 co-lead investors, we're still going to offer a 10% discount to anybody that invests before the end of the year. Plus, we're going to give you a jar of our spoils from the world's first plasma bored tunnel, because that TBR is out in basically near Fresno testing. And so we're going to, as I think I mentioned, we're going to bore a 10-meter long, roughly 40-foot long tunnel. All right, so I'll pause there, and I'm going to keep the sharing up, but I think we'll go ahead and start diving into Q&A here.
So question number 1 is what's the current market valuation?
Yep. So 95 million pre-money, and that would be if we assume we'll oversubscribe, we'll probably raise 10 million in this round. So if we do that, then that would be 105 million post money. By the way, and I should also mention, Bank of America has been working with us for about 18 months now. They've come to see our technology live and in action more than once. They've helped us create a whole new data room and financial projections and so forth. And they want to take us public in 2028 or 2029, assuming we get some of the boom contracts signed and some of those projects, fairly well along on development. So that's the exit.
Okay. And then I'm not sure if you just said it, but the total number of outstanding shares is another question.
Yeah, it's about, oh gosh, I think it's about 20 million. I'd have to pull up the cap table, but around 20 million outstanding shares, something like that.
And that will change as we use this price around this Series A to convert safes. So we're still in the final negotiations on that. So if th this 10% discount opportunity is on that safe by the end of the year, that would be your best way to sort of guarantee the best pricing. And then anything beyond that will be going into this price round directly.
How does the cost advantage compare to overhead when the ground is just dirt, no granite or other difficult materials to bore through?
Our advantage is not in dirt unless it's a tunnel, then we can go through anything. Dirt, all the organics would just vaporize. So if it's mixed soil or mixed geologies and we're going through dirt, soft rock, combination of soft rock or hard rock, and the ground is not homogeneous, you get all different kinds of things. So for just general tunneling, even through dirt, we think we're going to be competitive. But if it's trenching, we're not the right solution. It's much faster and easier just to use a typical excavator for trenching in dirt.
Does the check generate any shockwave, or do you ever get fouling due to any rock particles melting?
So there's no shock wave because we're non-contact. We don't actually touch the rock. It's energetic boring and excavation rather than mechanical. So no on the shock wave. There is some melt. If there's silica in the rock, we can get up to 20% of the spoils can be lava or magma. And that was a difficult problem to solve is how do you remove lava from a tunnel? And that's why it took us 7 different iterations on our spoils removal system to turn lava into silica sand. But we got that solved after breaking a lot of things and making a lot of mistakes. And yeah, that the code name for that was Thunderdome. To develop the spoils removal system that can deal with lava. In some rock, like limestone and some other types of rock, there can be zero silica, so there would be no lava, but it just depends on the geology. But again, we have that solved.
So I have a question about peak electric power demand, what it is. So what's the peak electric power demand? What is the electric power consumption per unit of work, let's say per kilometer?
Yeah, it's a good question. There's some misinformation out on the internet about EarthGrid in terms of how much power our machines require. It's really not that much. I'll go back to the slide that shows the 2 machines. On the left, the tunnel boring robot, that needs about 1.5 megawatts of power for the torches and another few hundred kilowatts, so call it 1.8 to 2 megawatts total to run that machine for a 1 meter diameter that can bore at, anywhere from 2 to 300 meters per day. That's what we're expecting, and possibly faster. So you can do the math on that in terms of 2 megawatts needed over that period of time. And we have models, of course, that would run all of this. The PES on the right, the plasma excavation system, needs less. It needs about 1 megawatt to run the torches and another few hundred kilowatts, so maybe 1.2 to 1.5 megawatts to operate that. So you can just use a generator, that's burning natural gas or gasoline or diesel, or in most cases, construction projects are planned in advance, right? You have to get your permits, and everybody knows that it's coming, and when the start, it's going to start, say, next June or whatever. And so there's plenty of time to arrange for temporary power from the grid to be brought to the construction site. And that's what's typically done for tunnel boring machines. If they're going to be boring a tunnel for whatever, they just use grid power. And so one of the companies out there that provides a mobile substation, they rent those. You can buy them too, but no real reason to unless we're doing lots of jobs in a row. But you can either buy or rent a mobile substation and get permission from the local utility, hook up to the grid and draw grid power. So again, 1.5 to 2 megawatts, so not very much power.
Does on that question they're also asking, does power depend on what type of materials being drilled through? Or-
Definitely. Yeah, our rate of progress varies based on the type of material. So for sure. And that's why we do like to get a little bit of geological information. We know we can go through anything. So, it's not that's one thing that's great about our technology is there's no geology risk. In a lot of other cases, like there was a project in New Zealand where they were doing a subway tunnel and they spent like, I think it was $11 million US equivalent to do a geotechnical baseline report, drilling core samples. Well, they missed several columns of basalt, really hard rock. The tunnel boring machine, which was, I think, like a $60 million machine that was custom built for that job, And by the way, many of those machines are built and left in the ground because they're like 100 to 200 meters long, longer than a soccer pitch. So the machine couldn't get through the basalt columns, so they had to back up and reroute, and the billions of dollars of delays and costs or whatever. I mean, I don't remember the math or the numbers, but this is really typical. We can get through anything. However, our speed does vary, and so we do like to know generally what's there so that we can give a pretty good cost estimate.
What about the vacuum system? So we have a question from Brody. Incredible tech. What type of vacuum removal systems do the Badass and Boom systems use?
Yeah, so the tunnel boring robot has the integrated vacuum system. It's line vacs. We actually filed a patent recently on our spoils removal system because, again, it took us quite a long time to develop that, and we're pretty proud of it. And then there's trade secrets around it that we didn't patent. But basically, we're using line vacs, total of four really powerful line vacs with venturi tubes that create a really powerful, suction. And then we're sending so much air through the torches, so there's a balance there. We're pushing air in front of the cutter head, and then the vacuums are pulling air and spoils out. We also have a heat exchanger, so we're recapturing a lot of the heat from the spoils, and reusing that. And anyway, and so uh, without getting into too much detail, it's basically vacuums. On the plasma excavation system, we've done a little bit of experimentation thus far. Often, the trench if it's trenching, the material just kind of blows up on either side of the trench. But we have heard from customers they want us to control that more, and so we're going to be integrating the same vacuum system onto the PES for those jobs.
You said that the plasma boring technology is the future of infrastructure. Why do you think it's the future of infrastructure? Why is that?
Yeah, because infrastructure in the United States is rather poor. The most recent grade or report card from the American Society of Civil Engineers, I think it came out at a C minus or a D plus. I forget what the latest one was. Infrastructure is crumbling and creaky and old in the United States, and that's typical for many developed nations and parts of the world. And so, to replace it, it's very difficult to go in and dig up a hole and pull out a pipeline that's an old water or sewer or wastewater line that might have been made with clay or cast iron steel or whatever. It's difficult to do that without line strikes, meaning breaking a fiber line and your internet goes out in your neighborhood, or a power line or whatever. This kind of stuff happens all the time. There's data on how costly our line strikes are to our US GDP. So the better way to do it is to dig deeper, go like, 3 to 5 meters deep, 10 to 15 feet below the spaghetti of all the other aging infrastructure that's there, and just put new stuff in and make it a larger tunnel that we like to call a utilidor. If it's larger, you can have multiple things in there. You can have water lines, power lines, and fiber lines all in the same tunnel. And in some jurisdictions, you can even add natural gas or hydrogen. In other jurisdictions, that would have to be a separate tunnel. We believe because we're so much faster and cheaper than other technologies, that we will be the future of pretty much any infrastructure, whether it's transportation in big tunnels for cars and trains, or if it's smaller tunnels for utilities.
Um, all right. So, can you speak to the percentage of opportunities in hard rock and road mount for non-hard rock tunneling and boring? Is that sure you'll understand that question?
Um, yeah, I'm not sure that I do understand that. Could you repeat?
So in our roadmap, I think obviously there's two ways of thinking about the future of infrastructure. What we view really as the long-term path forward for EarthGrid and honestly globally for underground infrastructure is to connect point A to B shorter through bedrock. As Troy mentioned, no line strikes. Traditionally, utilities take these meandering, crazy paths to avoid rock. So as soon as we get rid of that, that's an option. There are obviously areas like Silicon Valley, just south of us here, where there's something like 1,200 feet before you hit bedrock, and other similar valleys, Central Valley in California, and similar. Our technology works in soft soil. It works in anything we've chosen to target hard rock first because that's what nobody today does well. But we've also got, for example, our Atlas portfolio of patents, the automated tunnel lining system, and other systems designed around soft soil and mixed geologies. If you think about our future tech roadmap, zero focused right now on our tunnel in hard rock, and then we'll sort of hit the next biggest opportunity that we believe that is under addressed in the market, which is cobbles, boulders, and mixed geologies.
Awesome. Thanks, Ben. Um, so we have a question about you mentioned you've done 1,000 meters per day. Where was that? What type of rock? Was that using the boring robot technology?
So that was the boring technology, but we haven't done 1,000 meters in a day. What we've done is we've measured our speed in terms of millimeters per hour or millimeters per minute. And if you extrapolate that out, okay, X number of millimeters per hour multiplied by 24, gosh, if we had this thing out in the field, it would have gone 1,000 meters a day. And that was in bluestone granite, was one of the, and another one was in limestone where we achieved those kind of speeds. But we've been developing the tech for the last 7 years. It's only been a few months ago that our first machine was commercialized, which is the excavator that you're seeing here on the screen. We did have an earlier version of this excavator with only one plasma torch, and we made a little bit of revenue on a project a couple of years ago for a wind farm developer, but it was a small project.
Troy, what about like operational issues to worry about for tunneling in a densely built out urban setting?
Yeah, for sure. So one of the things that is interesting about our tech is because we're non-contact, we don't have a restriction really on turning radius. Other tunnel boring technologies do. They can't turn. If it's as long as a football field or a soccer pitch, you can imagine that it's a pretty gradual turn. Whereas because we're non-contact, once we mount it onto basically a little tractor, it can take a right turn or a left turn and not have to come up for air. That means there's a lot less disruption in an urban environment. You don't have to, tear up streets or sidewalks and, close down traffic lanes and all the stuff you see all the time. So that's kind of interesting. Also, we're not afraid of hard rock, so we can go deeper. Like for instance, we've been talking to Con Ed in New York, where we're going to have to go, more than 100 feet deep. Same with the utility in Singapore, and we've been asked to bid on a project in San Francisco, also very urban. And so we can go, 30 meters, 100 feet deep if necessary, even in that hard bedrock, because we can get through it so easily. Our cost is not insane like other technologies to be able to go that deep and have that that um, mitigation effect on traffic and surface disruption.
So on the finance side, are you planning on another ECF round?
Yes, we're going to have another CF or crowdfunding round. It's going to be on WeFunder. That will be after we uh, convert the safes and convert this round from convert all the safes and it's a price round. And so the lead investors are reviewing the documents now. So hopefully in the next several weeks, they'll sign those, and then we'll be able to launch probably in February on WeFunder. And I believe we can raise up to 5 million on the WeFunder platform. Um, we will not do that if we raise enough money in this round before that happens, from traditional investors. And we have a lot of traditional investors looking at us. There are VCs who are investing in this round, as well as family offices and even institutional family offices having a really hard look. And we just got a $10 million convertible note offer from 4 family offices as well. So we're exploring different options. So we're not 100% sure we're going to do the crowdfunding route. I will say that, however, that crowdfunding is one entry on the cap table. And so that's kind of nice.
Actually, I had this question too about geothermal market. I was just reading a piece. There's a major geothermal development going on. But are you thinking about bringing the technology to the geothermal market? And
For
can
sure.
technology go down and then horizontal is the follow-up that to that question?
Yeah, definitely. And in fact, we signed a contract last week with a geothermal company that has basically it's a binding contract or an MOU, I guess it is, but they have agreed to not only invest a bit into this round, but it's $1 million payment to do the engineer. So EarthGrid's going to earn $1 million or just a little less than that after some of the fees and costs or whatever. But they're hiring us to make modifications to our 1 meter diameter tunnel boring robot for geothermal applications. They don't want it to go vertical, which would be even more engineering work for us. Instead, they're like, hey, can you go down at like a 60-degree angle diagonally and heat rises, right? And so it'll actually have better thermal transfer if we're going down to the depth they need at a diagonal. It's a longer tunnel, obviously, that way. But so yes, EarthGrid is planning on making the modification, doing the design work to know what it's going to cost to build a geothermal ready tunnel boring robot. And we believe that there's huge potential in the geothermal market. And because our cost of boring is, and drilling is so low, if our electricity price is low, then we believe we can make a huge impact on the geothermal industry.
Is there any more risk, tech risk at this point, or is it primarily execution risk or something else?
Great question. No, there's no more tech risk, and you don't have to take our word for it. We've been told that, with respect to our excavator, that it's ready to go. With the tunnel boring robot, it's minor stuff. There's no real, significant tech risk at all. It's just okay. Well, we gotta make sure this sensor doesn't fail or melt, or we're testing it right now and we're learning a lot. So there's kind of those little issues, but the major tech subsystems have all been developed and tested over the last 7 years, and primarily the most difficult one is the one I already mentioned, the spoils removal system.
Are you signing any contracts or plans for transmission work with data centers?
Definitely. That's the most active customer market for us. We have a ton of data center developers who are talking to us directly, as well as construction companies and others in that world who are also talking to us. Because think about it, if it takes 15 years to build a new transmission line and data centers need all this power, and they can't get a nuclear power plant permitted for 5 years or 10 years or whatever, assuming that technology is available right now, and there's only so much natural gas generation that they can put in and on site on the data center. There really aren't any other solutions. But if we can be their underground extension cord and provide, using our utility status, provide an extension cord bringing solar and wind power from 20 or 40 or 80 miles away, that's a solution that can be permitted and built in about a year or two. And so, yes, there's tremendous interest, and that's why we have so many people watching us right now to see that tunnel boring robot go, because that's the real exciting product. Excavating, digging ditches, yeah, that's cool, and that's going to be needed here and there. But tunneling is so much less disruptive to the surface and can just follow along the roads, and that's why folks are so excited about that machine, which, again, I've been waiting almost 9 years for that machine to go out into the field, and it's in the field right now. We started boring for the first time last week.
A few more questions here. So question on wasn't the prior net capital round a price round, and was this too small to trigger conversion?
It was a price round, but it was for common shares rather than preferred shares. This round is preferred, and we're going to be offering the preferred shares on the WeFunder platform.
And then a question about you had mentioned PG&E and that they were top left of the splash slide, potential customers. Can you share anything about your discussions with PG&E?
Yeah, we were awarded a pilot project with PG&E as part of a program, and then they had to go get funding from the CPUC to advance their undergrounding program, which they did get. And so we're in regular discussions with them, and they're looking for projects for our excavator, and they're waiting for our tunneler to be commercialized and ready to go. They asked us to bid on 2 tunneling projects. So we're in regular discussions with PG&E, and we hope to get our first project sometime in 2026 with them.
I think there's a hidden advantage there, though, in that we're going to become probably one of the leading providers of subsurface data as we tunnel around the world. And so I think there's going to be a lot of ways for us to access and monetize that data as we're exploring different areas and even identifying new areas of critical mineral deposits within the United States and abroad.
Question regarding mineral rights. Do you need to worry about mineral rights or their access rights?
Under public road, in most jurisdictions, no, that's already taken care of, meaning the county or the city or the state, whoever owns or controls that roadway, also controls the mineral rights. And so our longitudinal permit that we apply for using our utility status, it covers all of that. But if we have to go under private property, then yeah, for sure, we would need a subsurface rights attorney to help us to navigate any potential mineral rights issues.
For Troy and Ben, like how do you scale to capture all the opportunities? Seems like there's a lot of companies interested right now. How do you scale that?
Yeah, it's going to be a good problem to have. I mean, we're at this exciting inflection point where we're about to get customer revenue and contracts, and I suspect, based on the interest, that we're going to have a supply problem, not a demand problem, and so we will have to scale. We've talked to a number of financial institutions, including Bank of America and others, that they have non-dilutive capital available for us to build more machines to meet the demand of these contracts and or make modifications to our existing two machines as needed to, meet whatever like the customer might want. Like I said earlier, the vacuum on the excavator. So we add that for a trenching project or carving out the side of a mountain to create a foundation and an equipment pad for a new transformer for Statnett, the grid operator in Norway. That's one of the projects that we're bidding on. So those are the kinds of things that 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 will need that non-dilutive capital for. The facility that we're in California, it's in Richmond, California, in the San Francisco Bay Area, north of Berkeley. It's a large building, and it's an old World War II tank factory, and we have the ability to take over additional space in that building to basically crank out as many machines as we need as customer demand increases.
One just thing to note on the scale side, there's quite a sort of moat that we've built just on the equipment and supply front. So we have exclusivity with the major torch suppliers, and we also have equipment on hand to build either one more PES or most of one more TBR. So depending on sort of where we're seeing the earliest commercial traction and interest between those, we do have sort of I'd call it a many month head start there.
Do you see EarthGrid like as you go into the market, is there going to be attractiveness for using this technology in the US and Europe? Is there a particular place where you're seeing more traction or more interest?
It's kind of a race. We're getting inquiries from all over the world, all over Asia, South America, Australia, Africa. But I think it's going to be down to the U.S. and Europe in terms of where we're going to get the most opportunity over the next 2 years, 2 or 3 years. It's data center development, it's solar and wind developers who have projects that are stuck. Like I said earlier, 80% of projects are abandoned or put on hold, and they want to get those projects unstuck by creating a transmission line or an extension cord, like I said, to get power from their facility to a substation that actually has capacity, or directly to a data center substation, or to a factory substation, or a corporate campus, or whatever. So yeah, Europe and the US are where we're seeing the most, and in some ways, Europe is winning that race right now.
Can anybody else do what you're doing in terms of creating these machines? How difficult is it?
Yeah, it's a great question. So there's only one other company in the world using plasma for any type of underground work, and that company is called GA Drilling. That stands for Geothermal Anywhere. We talked about geothermal earlier. They are based in Slovakia in Eastern Europe. They do have a testing facility that they rent in Houston. We've been in touch with them. They are focused on geothermal or vertical only, and so that's why we're going diagonally instead of vertical. One of the reasons why. However, I've been talking to Igor, their founder, for years. We asked if we can buy any of their plasma bit, technology, their torches. And he's like, no, we're not ready yet. They're not commercially available yet. So they're several years behind us. We actually think they're a really good acquisition target. But if we wanted to do anything vertical, we would have to license their patents and vice versa. If they wanted to do anything except vertical, meaning horizontal or any type of diagonal, they would have to license our patents. And so the answer is no. No one else can use plasma for underground construction anywhere in the world without infringing on our patents. So that gives us the first level of protection. And then, as I mentioned earlier, we have our trade secrets. It takes a while to figure out the right recipe for each type of rock, the variables that can be modified to optimize the progress. And that takes a long time. So you have to, buy all this equipment. Takes a year and a half to get all the equipment in because it's all custom built. Then you can start testing. It takes, months and months of testing to figure all this stuff out. And so it would take a while to recreate all of that. But a competitor would have a hard time, outside of China, a competitor would have a hard time buying the equipment they need to build a system to compete with us, because we have exclusivity with key suppliers.
There's a question, is the manufacturing facility in Richmond, California, the former Ford assembly plant?
No, it is not. It's 1 West Barrett Avenue in Richmond, and it's the tenant before us was Marway Steel, but anyway. No, that's the building.
But ironically, we have looked at that building. We bought equipment from there, and our best fabricator is from a company that was formerly based there. So you're not far off. We're shooting distance from it.
That's true.
Nice. Well,
Yeah.
why don't we conclude on a fun question? Is the plasma tech used in space? Can you use it in space, or is it earthbound tech only?
Funny you should ask. Just about 3 weeks ago, well, first of all, my son, who's a senior in high school, loves space, and he came up with the idea of using the tech for asteroid mining. I was like, huh, I wonder if that would work. And so we researched it, and yeah, sure enough, it would work. And one thing led to another. And so 3 or maybe 4 weeks ago now, we met with a high-level person at NASA who's super geeked out about our tech for habitations on the moon and in Mars. And so there's a number of applications in space, and he's like, yeah, with powers is not that hard. You can get solar power and energy storage. We'd have to have some type of a gas, so you can either create the gas locally. There's all different options in terms of the gas to run through because there's no air, right? But yeah, he's like, this is going to be super interesting for habitations and for mining applications on the moon and in the asteroids and other celestial bodies. And that's another application of our tech here on Earth as well. We are talking to a number of mining companies, and they've told us that our tunnel boring robot, if we're going to be able to, because it's flexible, right? It can move, it can turn up, down, left, right. And so for following, say, a vein of gold or platinum or silver or copper or whatever, we can follow it. And our process, our tunnel boring robot eliminates the first 5 to 6 steps of their process. They do drilling, then they do blasting, then they do primary crushing, secondary crushing, and separation, or removal and then separation. And we do all of that. We basically turn everything into sand and dust. And so any ore turns into little like globules, like BB-sized spheres. And that's pretty easy to separate post-process. So yeah, we do think this tech will be used in space. And we're being looked at by some VCs in the space tech world who seem to be pretty interested.
And yeah, we're an early commercial company, so truly, if you've got pesky hard rocks, it'll be an expensive backyard project. But we love to hear about these pockets of rock that are causing issues in your local communities, or places that are close to you. That's how we figured out through the grapevine that Norway had a lot of really pesky rock problems that we believe we can solve, both in transportation and in grid. And similarly, we've gotten just some hints from within our community about folks to reach out to. So keep those ideas flowing. And if you are looking to invest, this is an amazing opportunity before the end of the year, to get those dollars in, make sure they count in 2025, and would love to answer any questions or follow-ups via email.
Yep. I do see one other question real quick. do we have the ability in our tunnel as a telecommunications utility to do power? And yes, the answer is yes. We can put power lines in our tunnel alongside telecommunications hardware up to the level that that state considers transmission. In most states, that's 69 kV. So 69 kV or less, we're able to put in our tunnel. If we go higher voltage than that, we need to get a waiver from the state utility commission, which there's a process for that. And last but not least, anyone who invests before the end of the year, we have an extra spiff. So reach out to Ben or I if you are interested. We will sweeten the deal for you. In addition to giving you a jar of spoils of the world's first plasma board tunnel. Yeah, there you go, like Ben just showed you. In addition to that, we also plan to offer a sweetener on top of the 10% discount. So let us know for those who are interested. We want to keep the capital coming in to keep the team doing everything that they need to do to keep testing the tunnel boring robot out in the field. Oh, thanks so much, everybody, for your attention today, and look forward to having one-on-one conversations with many of you.